Laplace transforms of common forcing functions. The first one is unit step function. This is the most common driving function in electrical engineering and is denoted by f of t equals to 0 for t is less than or equals to 0 and equals to 1 when t is greater than 0, and the function has no magnitude for the t is less than 0 and has the positive unit magnitude at t is greater than 0, and graphically it is represented like this. T is f of t. Before 0 this value is 0 and at 0 it reaches a unit value 1 and it will be 1. Now Laplace transform, that is f of s for this unit step function, that is L of f of t is given by integral 0 to infinity e power minus st dt, which will be e power minus st by s within the limits 0 and infinity. For infinity e power st is 0, for 0 e power st is 1. So now substitute these values. 0 minus of minus 1 by s, which equals to 1 by s. For this f of s equals to 1 by s. Let it be equation 8. The unit step function in electrical circuit representing the closing of a switch applying constant voltage V to the circuit. Then the Laplace transform for this will be V by S unit step function. Now the second one, exponential function. Exponential function being also very common in electrical circuits, and it is described as f of t equals to e power minus at. In a diagram with t, f of t. Now applying Laplace transformation, that is f of s equals to Laplace transform of f of t, that equals to integral 0 to infinity e power minus at of e power minus st dt. Now this is two exponential functions, 0 to infinity, then e power minus a plus s of t dt. And you are going to get e power minus a plus s of t divided by s plus a minus. For this 0 and infinity. Now for infinity value, if you substitute infinity, then this will become 0. For 0 value, it will be 1 and minus of minus plus. So f of s finally you are going to get for this function is given by 1 by s plus a for exponential function. Now third one, the sinusoidal function. The function being extremely commonly used in the circuits encountering an AC supply or AC source, the sinusoidal function in time domain in exponential form is represented with f of t equals to sine omega t, that equals to e to the power of j omega t minus e to the power of minus j omega t divided by 2j. And in graphical representation, the sinusoidal will be 0 to maximum 1 to 0, maximum negative to 0. Hence, the Laplace transform of the sine wave, that is Laplace transform of sine omega t, is given by integral 0 to infinity e to the power of j omega t minus e to the power of minus j omega t divided by 2j multiplied by e power minus st dt. Now, you can separate this by taking common 2j out of it, and e power j omega t multiplied by e power minus st, that will be e power minus s minus j omega of t minus e power minus s plus j omega of t dt. You have to integrate between 0 and infinity. If it does that, you are going to get 1 by 2j of 1 by s minus j omega minus 1 by s plus j omega. Then if you simplify this, you are going to get omega divided by s square plus omega square. Let it be, this is 9 and this is 10, then this is 11 and this is 12. The fourth one, the cosinusoidal function, which is given by f of t is equals to cos omega t. You can solve this by taking into exponential form or else from the derivation of the sinusoidal function also. So if we have a function that sine omega t, then d by sine omega t of dt is given by cos omega t of omega, then from which you can write that cos omega t equals to 1 by omega of d by dt of sine omega t. Let this be equation number 13 and this be 14. Cos wave. This is f of t for the cos function and this is t. Now, the Laplace transform of cos omega t is nothing but f of s of the cos function. From equation number 4, Laplace transform of f dash of t equals to s f of s minus f of 0 plus. Then, for our function, that is f of s of cos, is given by the 1 by omega of s of f of s minus f of 0. However, the f of s is nothing but this value. So substitute that value in this, then you are going to get 1 by omega of s of omega divided by s square plus omega s square minus the initial term is 0. When you solve this, you are going to get s by s square plus omega s. So the Laplace transform of cos omega t is equals to s by s square plus omega square, whereas the Laplace transform of sine omega t equals to omega divided by s square plus omega square. Question number 15.